Welcome to CyberPod 6, where we are always finding new ways to share the cybersecurity knowledge. Today we will be breaking down the history of network printing and wrapping up with how Linux manages it all through a system called CUPS. Let's get into it. In the early days of personal computing, printers were directly attached to a single desktop machine. That was the only computer that could use it. No sharing, no networking. If someone else in the office needed to print, they either had to walk their files over on a floppy disk or wait their turn at that one machine. Not exactly efficient. Then came peer-to-peer networking, think Windows 3.11, and suddenly computers could communicate directly with each other. You could share a printer over the network, similar to how you'd share a folder. Other users could send print jobs to it remotely, as long as they had a local account with the right permissions. But there was a significant limitation. The host computer, the one physically connected to the printer, had to stay powered on. Shut it down, and the entire network lost access to that printer. The next evolution came when printers started shipping with their own network interface cards, NICs. This meant the printer could connect directly to the network switch, just like any other device. No host computer required. The printer was now independently accessible to anyone on the network. The catch? Every workstation still had to be individually configured and authorized to communicate with that printer. It was progress, but management was still distributed and time-consuming. This is where centralized management entered the picture, the dedicated print server. Rather than configuring every computer to talk to every printer, you'd set up a server running print server services, connect all your network printers to it, and manage everything from one place. The server stays on around the clock, handles the print queue, and gives administrators centralized control over permissions and printer access. A much cleaner architecture. On Linux, this role is handled by CUPS, the Common Unix Printing System. CUPS functions as both a universal translator and a traffic controller for your print jobs. Because printers from different manufacturers speak completely different languages, CUPS abstracts all of that complexity away. It converts your document into a format the target printer understands, then manages the job queue so everything gets processed in an orderly fashion. CUPS runs as a background service and listens on port 631. That's the default port for the IPP protocol, the Internet Printing Protocol, which is how modern systems communicate with printers. If you're administering CUPS from the command line, these are the 6 essential commands you need to know. Master these, and you've got solid command line control over your entire print environment. Thanks for joining us on this cybersecurity journey. If you enjoyed this content, smash that like button, subscribe to the channel, and drop a comment below.